the secrets of cat sleep, what they really dream about. Welcome, dear wanderers of the night, to another journey into the mysteries of the animal mind. Tonight, we'll slip quietly into the world of our most enigmatic companions, the domestic cat. As the evening settles around us and shadows lengthen across your room, I invite you to curl up, just as a cat might, and drift with me into the fascinating realm of feline sleep and dreams. There's something deeply mesmerizing about watching a cat sleep, isn't there? The way they curl into impossible circles, the gentle rise and fall of their breathing, those sudden twitches of whiskers and paws that hint at adventures unfolding behind closed eyelids. For thousands of years, cats have shared our homes, our hearths, our beds, yet their inner lives remain beautifully mysterious. What happens when those luminous eyes finally close? Where do their minds wander during those long hours of slumber? Tonight, we're going to explore these questions, and the answers might surprise you. The science of cat sleep is far more intricate than most people realize. It's a story that spans continents and centuries, involving dedicated researchers who spent countless hours observing sleeping cats in laboratories, behavioral scientists who decoded the meaning of every twitch and murmur, and pioneering neurologists who quite literally map the dreaming brain. This is a story about consciousness itself, about the universal experience of dreaming that connects us to our feline companions in ways we're only beginning to understand. So settle in, let the day's tensions drain away, and prepare to see your cat, and perhaps yourself, in an entirely new light. The masters of sleep. If there's one thing cats have perfected over millions of years of evolution, it's the art of sleep. These remarkable creatures spend anywhere from 12 to 18 hours each day in slumber. With some individuals, particularly kittens and elderly cats, sleeping up to 20 hours. Research suggests that cats spend anywhere from 50 to 70% of their entire lives asleep, depending on their age, health, and lifestyle. To put this in perspective, if a cat lived as long as a human and slept for an average of 15 hours daily, they would spend roughly half their lifetime in slumber. This might seem excessive, lazy even, but there's profound evolutionary wisdom in this behavior. To understand why cats sleep so much, we need to journey back in time, back to the sun-baked savannas and deserts where the ancestors of our modern house cats first emerged. These ancient felines, particularly the African wildcat Felis sylvestris libica, faced a challenging existence. They were simultaneously predators and prey, hunters who could themselves be hunted. This dual nature shaped every aspect of their biology, including their relationship with sleep. Unlike herbivores, who must spend most of their waking hours grazing to extract enough nutrition from plant matter, carnivores like cats obtain their energy from nutrient-dense meat. A successful hunt could provide enough calories to sustain them for an entire day or more. But here's the critical detail. Hunting is extraordinarily energy-intensive. The explosive bursts of speed, the patient stalking, the lightning-fast reflexes required to catch prey, all of this demands tremendous physical resources. The solution that evolution arrived at was elegant. Cats became masters of energy conservation. They would rest for long periods, allowing their bodies to recharge, then explode into action during optimal hunting times. This strategy proved so successful that it's hardwired into the biology of every cat alive today, including the pampered house cat dozing on your sofa who hasn't had to hunt for a meal in their entire life. But when, exactly, are these optimal hunting times? Here's where we need to dispel a common misconception. Cats are not nocturnal, despite what countless cartoons and cultural references might suggest. Cats are not creatures of the night in the same way that owls or bats are. The technical term for their activity pattern is crepuscular. They are animals of the twilight, most active during dawn and dusk. This crepuscular nature is another brilliant evolutionary adaptation. During twilight hours, temperatures in their ancestral desert environments were more moderate. Neither the scorching heat of midday nor the dangerous chill of deep night. More importantly, these twilight hours coincided with the activity patterns of their prey. Small rodents, birds beginning their morning routines, insects emerging in the cooling evening air, all became available targets during these liminal hours when light and shadow mingle. The cat's eyes evolved to take maximum advantage of these low-light conditions. Their retinas contain a high concentration of rod cells, which are exquisitely sensitive to dim light. Behind the retina lies a reflective layer called the tapetum lucidum, the structure responsible for that eerie eye shine you see when light catches a cat's eyes in darkness. This layer acts like a biological mirror, reflecting light back through the retina and giving the photoreceptors a second chance to capture photons. It's this adaptation that allows cats to see in light levels 6 times lower than what humans require. But even with these remarkable visual adaptations, cats still need to conserve energy between their bursts of hunting activity. And so, they sleep. They sleep in patches throughout the day and night, following what scientists call a polyphasic sleep pattern. Unlike humans, who typically consolidate our sleep into one long nighttime period, cats take multiple naps scattered across the 24-hour cycle. These naps typically average around 78 minutes, though they can range anywhere from 50 to 113 minutes, depending on how deeply the cat sleeps and how secure they feel in their environment. These aren't all the same type of sleep, though. And this is where things become truly interesting. Because when we look closely at the structure of cat sleep, when we peer into the sleeping brain, we discover a complexity that rivals our own. We discover something that, for decades, scientists believed was uniquely human. We discover that cats dream. The architecture of feline sleep. Imagine for a moment that you could watch a cat's brain activity as they drift off to sleep. You would see something remarkable. The brain doesn't simply switch off, like flipping a light switch. Instead, it transitions through distinct stages, each with its own characteristic patterns of electrical activity, each serving different functions for the sleeping animal. Scientists studying cat sleep identify 4 main states across the sleep-wake spectrum. Wakefulness, which includes periods of drowsiness. REM sleep, which we'll explore in depth shortly. And 2 types of slow-wave sleep, termed light and deep slow-wave sleep. Understanding these stages requires us to think about sleep not as a single state, but as a dynamic process, a carefully choreographed dance of neural activity. When a cat first settles down to rest, they typically enter a period of alertness mixed with drowsiness. You've probably seen this. The cat is lying down, perhaps with paws tucked under their chest in the classic loaf position, but their eyes are still open or only half closed. Their ears swivel toward sounds. They're resting, yes, but they remain connected to their environment, ready to spring into action if needed. This is light sleep, or what scientists call non-rapid eye movement sleep, often abbreviated as NREM. During this initial phase of sleep, the cat's muscles remain somewhat active. their body temperature stays regulated. Brainwave patterns, as measured by electroencephalogram or EEG, show a characteristic shift from the irregular rapid patterns of wakefulness to longer, more regular waves. This light NREM sleep serves a crucial function. It allows the cat to rest and begin the process of physical restoration while maintaining enough awareness to detect potential threats. In the wild, this state-dependent vigilance could mean the difference between life and death. A cat who slept too deeply might miss the approach of a predator. A cat who remained too alert couldn't properly rest. Light NREM sleep strikes the perfect balance. After cycling through this light sleep stage, the cat's brain may rouse briefly back to alertness, then dip back into sleep. This happens multiple times. It's not unusual for a cat to transition between alertness, drowsiness, and light NREM sleep several times before finally progressing to deeper stages. Eventually, if the cat feels sufficiently safe and comfortable, they'll transition into deep, slow wave sleep. Their posture often changes at this point. The tightly controlled loaf position relaxes. They might roll onto their side or even onto their back with paws in the air. Their muscles below the neck relax more fully. The EEG patterns show even slower, higher amplitude waves, the slow oscillations that give this stage its name. Research has shown that cats with larger amounts of deep, slow wave sleep also tend to have larger amounts of REM sleep. There appears to be a positive correlation between these two stages, suggesting they work together in some complementary way. Interestingly, the amounts of light slow wave sleep show a negative correlation with deep slow wave sleep. When one goes up, the other tends to go down. This delicate balance between sleep stages reflects the complex regulatory mechanisms that govern the sleeping brain. Deep, slow wave sleep is where the serious work of physical restoration happens. Growth hormones are released. Cellular repair processes accelerate. The immune system strengthens. Metabolic waste products that accumulated during wakefulness are cleared from the brain through a remarkable system called the glymphatic system, a kind of waste removal system that becomes much more active during deep sleep. This stage is particularly important for young growing cats and for older cats whose bodies need extra time for maintenance and repair. As cats age, their sleep architecture changes in fascinating ways. Elderly cats, typically those over 10 years old, tend to have less REM sleep and more non-REM sleep overall compared to young adults. They also experience more brief awakenings, those 6 to 14-second interruptions that fragment their sleep. These age-related changes are remarkably similar to what happens in aging humans, suggesting that the mechanisms underlying sleep regulation are deeply conserved across mammalian species. But here's what makes cat sleep truly fascinating. After cycling through slow wave sleep, something extraordinary happens. The sleeping cat enters a state that, when it was first discovered, seemed to contradict everything scientists thought they knew about sleep, a state so paradoxical that the researcher who discovered it, a French neurophysiologist named Michel Jouvet, called it paradoxical sleep. We now know this state by another name, REM sleep, rapid eye movement sleep. During REM sleep, the cat's brain activity changes dramatically. The slow, synchronized waves of deep sleep give way to rapid, irregular patterns that look remarkably similar to the waking brain. The EEG becomes desynchronized, showing the high-frequency, low-amplitude activity associated with active thinking. Yet the cat is clearly asleep. Their eyes are closed. Their breathing becomes faster and irregular. Their heart rate fluctuates. And most distinctly, if you watch closely, You can see their eyes moving beneath their closed lids. Rapid, jerky movements, horizontal sweeps, vertical shifts, between 8 and 30 separate eye movements per burst. These movements are not random. They appear to correlate with the content of dreams, as if the sleeping cat is watching the events unfold in their mind's eye. The muscles of the face might twitch, whiskers tremble. The paws make small running motions. The tail flicks. Some cats vocalize, tiny meows or chirps or even growls. It's during these moments that pet owners often wonder, what is my cat dreaming about? But here's the truly remarkable thing about REM sleep. Despite all this neural activity, despite the brain being as active as during wakefulness, the cat's major muscle groups are essentially paralyzed. Scientists call this state muscle atonia. The sleeping cat cannot move their limbs in the coordinated way they would while awake, even though their brain may be commanding them to run, to pounce, to climb. This paralysis is not accidental. It's a crucial safety mechanism, and its discovery opened up entirely new fields of neuroscience and sleep medicine. The story of how we learned about REM sleep atonia and what it tells us about dreams is one of the most fascinating chapters in the history of brain science. The revolutionary discovery of Michel Jouvet. The year was 1959. In a laboratory in Lyon, France, a young neurophysiologist was conducting experiments that would forever change our understanding of sleep and consciousness. His name was Michel Jouvet, and he was trying to understand the neural mechanisms underlying different states of awareness. Jouvet had begun his research journey several years earlier, in 1954, working in California at the laboratory of Horace Magoon, a neuroscientist who, together with Giuseppe Maruzzi, had been instrumental in identifying brain structures underlying sleep and wakefulness. There, Jouvet was initiated into the cutting-edge field of sleep research. But it was back in Lyon, in his own laboratory at INSERM, the French National Institute for Health and Medical Research, that he would make his most significant discoveries. Jouvet's path to sleep research had been circuitous and shaped by history. Born in 1925 in Lons-le-Saunier in the Jura region of France, he initially wanted to become a sailor, but World War II intervened. He served as a sergeant, witnessed the sabotage of the French fleet at Toulon, and was medically evacuated. These experiences redirected his ambitions toward medicine and science. After completing his medical studies in Lyon, he became a specialist in neurology and neurosurgery, particularly interested in understanding consciousness and the loss of consciousness in comatose patients. This early work would lead him to establish, for the first time, the electrophysiological criteria for brain death, a contribution that would save countless lives by providing clear diagnostic guidelines. Jouvet's initial research focused on identifying the brain structures necessary for consciousness. He worked primarily with cats, using techniques that were state-of-the-art for mid-20th century neuroscience, though they involved invasive procedures that would be approached differently today. He created what were called pontine cats, animals in which portions of the brain anterior to the pons, a structure in the brainstem, had been removed. This allowed him to isolate which parts of the brain were essential for various functions. But it was during routine observations of intact, sleeping cats that Jouvet noticed something peculiar, something that surprised him very much, as he would later write. He observed that cats, as they slept, would occasionally enter a state characterized by complete muscle relaxation below the neck. The EEG showed patterns of rapid, activated brain waves similar to wakefulness. The eyes moved rapidly beneath the closed lids, yet the cats were clearly asleep. They did not respond to gentle stimuli. Their bodies lay utterly limp. This was paradoxical. Sleep was supposed to be a state of brain quiescence, of reduced neural activity, yet here was a sleep state where the brain appeared to be working as hard as during wakefulness. Jouvet called it sommeil paradoxal, paradoxical sleep. Others were studying similar phenomena at the same time. In the United States, Eugene Aserinsky and Nathaniel Kleitman had identified rapid eye movements during human sleep in 1953. William Dement would soon coin the term REM sleep. But Jouvet's work was unique because he was asking deeper questions about the mechanisms. What brain structures generated this state? What purpose did it serve? And why were the muscles paralyzed? To answer these questions, Jouvet designed a series of elegant experiments over the following years. In the mid-1960s, he created precise lesions in specific regions of the brainstem, particularly around an area called the locus coeruleus in the dorsal pons. Then he observed what happened when these cats slept. The results were startling. Cats with lesions in this particular region still showed all the EEG characteristics of REM sleep. Their brains still entered the activated wake-like state. Their eyes still moved rapidly, but the muscle atonia was gone. The paralysis that normally kept the sleeping cat motionless had disappeared, and the cats began to act out their dreams. Picture this. A cat lies sleeping in the laboratory, electrodes gently attached to their skull to monitor brain activity. The EEG shows the characteristic patterns of REM sleep, but instead of lying still, the cat suddenly rises. Their eyes remain closed. They are undoubtedly still asleep, but they begin to move. They walk. They crouch. Their head turns, tracking something invisible. Their body coils into a hunting posture. They pounce at the empty air. Their claws extend and retract. They make biting motions. Some cats would exhibit what Jouvet termed oniric behavior, dream behavior. They appeared to be hunting prey that existed only in their sleeping minds. Some would exhibit rage behaviors, arching their backs, hissing at unseen threats. Others showed exploratory behaviors, as if navigating terrain that wasn't physically present. The movements weren't random or chaotic. They were organized, purposeful, following the logical sequences of waking behavior. A cat might stalk, crouch, wiggle its haunches in preparation, and then pounce, the complete hunting sequence, performed while utterly asleep. The brain was generating the full motor program. Only the absence of muscle atonia allowed these commands to be executed. This discovery was revolutionary for multiple reasons. First, it provided concrete evidence that the brain actively generates specific movements during dreams, movements that are normally suppressed by the paralysis mechanism. Second, it showed that this paralysis served an essential protective function. Without it, dreamers would physically act out whatever scenarios their sleeping brains conjured. Third, and perhaps most importantly, it suggested that the content of dreams in cats was not random, but reflected their waking experiences and instincts. These cats were dreaming of hunting, of stalking, of capturing prey, of confronting threats. Their sleeping brains were rehearsing the very behaviors that defined their existence as predators. Jouvet's work laid the foundation for decades of subsequent research. Scientists could now study dreams objectively by observing behavior and brain activity, rather than relying solely on subjective reports from human dreamers. His discovery would eventually lead to the identification of REM sleep behavior disorder in humans, a condition where people, like Jouvet's lesioned cats, lose the normal paralysis of REM sleep and act out their dreams, sometimes with dangerous consequences. This disorder, first described clinically in the 1980s, has since been recognized as an early warning sign for certain neurodegenerative diseases like Parkinson's disease and Lewy body dementia. Jouvet's curiosity-driven basic research with cats ultimately led to medical advances that affect millions of human lives. Jouvet himself remained fascinated by dreams throughout his career. He kept his own dream diary, collecting thousands of dream reports. He wrote several books on dreams and dreaming, though most were published only in French. He proposed theories about the function of REM sleep, suggesting it might serve as a kind of genetic programming system, a way for instinctive behaviors to be rehearsed and maintained even without practice during waking hours. While not all his theories have been fully validated, his willingness to ask bold questions and submit them to rigorous experimental testing embodied the best traditions of scientific inquiry. He passed away in 2017 at the age of 91, leaving behind a legacy that transformed our understanding of sleep, dreams, and consciousness itself. But for our purposes, Jouvet's experiments proved something profound. They demonstrated beyond doubt that cats experience something analogous to human dreaming. Their brains generate complex, coordinated behavioral sequences during sleep. They have an inner life that continues even when they're unconscious. The cats were dreaming. The question remained, what exactly were they dreaming about? When cats dream? The evidence that cats dream is now overwhelming. It comes from multiple lines of research, each adding another piece to the puzzle of feline consciousness. Let's start with the basics. Cats, like humans, spend a significant portion of their sleep time in REM, the stage most strongly associated with dreaming. Michel Jouvet's pioneering research in the 1960s found that cats spend approximately 15% of their total time. Not just sleep time, but their entire 24-hour day, in this paradoxical sleep state. When we look at just their sleeping hours, some studies suggest this REM percentage can be even higher. Each individual REM episode typically lasts between 5 and 15 minutes, though this can vary. Over the course of a day, research suggests an adult cat might cycle through dozens of separate REM periods, each one potentially containing its own dream narrative. During these periods, the physiological signs are unmistakable. Brain activity, as measured by EEG, shows the characteristic low voltage, high frequency patterns, indicating widespread neural activation. The eyes move rapidly behind closed lids, making an average of 8 to 30 movements per burst. These movements occur in both horizontal and vertical directions, a detail that matters because it suggests the cat's visual cortex is generating imagery that the sleeping brain tracks as if it were real. The breathing becomes irregular. The heart rate fluctuates. In young cats, particularly kittens, REM sleep appears to occupy a larger percentage of total sleep time, though exact figures vary across studies. This makes sense from a developmental perspective. Young brains have enormous amounts of new information to process and integrate. The heightened REM sleep in kittens likely serves important roles in brain maturation, memory consolidation, and the rehearsal of instinctive behaviors. But the most compelling evidence comes from the physical movements. Watch a cat in deep REM sleep, and you'll see a remarkable display. The paws twitch and paddle, making small running motions. The claws extend and retract. The ears swivel. The whiskers tremble. The tail flicks back and forth. Some cats vocalize, those tiny muffled meows or chirps that seem to come from far away. What's happening in the brain during these moments? Research conducted at Massachusetts Institute of Technology provides fascinating insights. Scientists trained rats to navigate through mazes while monitoring their hippocampal activity. The hippocampus is a structure deep in the brain that's crucial for spatial memory and navigation. They found that specific patterns of neural firing corresponded to specific locations in the maze. When the rat was in position A, neurons fired in pattern A. When it moved to position B, the pattern changed to pattern B. Then they monitored the rats during sleep, and they found something extraordinary. During REM sleep, the hippocampus replayed those same patterns. The sleeping rat's brain was essentially rehearsing the route through the maze. The scientists could determine, based solely on the neural activity, where in the maze the sleeping rat was dreaming of being. While similar studies haven't been conducted in cats with the same precision, all available evidence suggests the mechanism is identical. The mammalian hippocampus appears to work the same way across species. When a cat sleeps, their hippocampus likely replays the day's experiences: the successful hunt, the climb to the top of the bookshelf, the confrontation with the neighbor's cat, the play session with that particularly delightful feather toy. But here's where it gets even more interesting. Dreams aren't just playback. They're not simple video recordings of waking experiences. The sleeping brain takes elements from multiple experiences, combines them, recombines them, creates new scenarios. This process serves multiple functions. First, it aids in memory consolidation. The brain sorts through the day's experiences, deciding what's important enough to transfer from short-term to long-term memory. That mouse that got away? Important. Definitely worth remembering and analyzing. That leaf that blew across the patio? Less critical. The dreaming brain performs this triage, strengthening some neural connections while allowing others to fade. Second, dreams allow for behavioral rehearsal. The sleeping cat's brain can practice hunting sequences, escape responses, social interactions, all without the risks or energy expenditure of actual behavior. This is particularly important for kittens and young cats, who are still learning the complex skills they'll need for survival. Their extended REM sleep gives them extra practice time. Third, dreams may serve emotional regulation functions. Experiences that generated strong emotions during waking, fear, excitement, aggression, affection, can be processed and integrated during sleep. This helps the animal maintain psychological equilibrium. It's why sleep deprivation has such profound effects on mood and behavior. What do cats dream about? Based on all available evidence, they likely dream about their lives. Research on other mammals, particularly the groundbreaking studies at MIT with rats, suggests that the sleeping brain replays experiences from waking hours. A cat who spent the afternoon watching birds through the window may well dream of birds. A cat who had an energetic play session probably dreams of chasing and pouncing. A cat who experienced something stressful, a visit to the veterinarian perhaps, or the arrival of a strange dog, might dream about that event as their brain works to process the emotional impact. Some dreams are likely pleasant, filled with successful hunts, satisfying meals, comfortable napping spots, and affectionate interactions with beloved humans. Other dreams might be less pleasant. Behavioral observations and what we understand about how the mammalian brain processes threatening experiences suggest cats can have nightmares. A cat who suddenly wakes from sleep looking disoriented or frightened may have experienced something disturbing in their dreams. Their body language tells the story. Flattened ears, dilated pupils, a bushed-out tail. The content of dreams is also influenced by the cat's individual history and personality. A cat who lived on the streets before being adopted might have more dreams involving survival scenarios, finding food, avoiding threats, seeking shelter. A cat who has lived their entire life in a safe, comfortable home might dream more about play and exploration. A cat with a traumatic past might replay those difficult experiences during sleep, their brain still trying to make sense of them. Interestingly, if cats do experience visual imagery during dreams, and current neuroscience suggests they likely do, those dreams might be painted in the limited color palette they perceive while awake. Cat vision differs from human vision in fascinating ways. They're essentially red-green colorblind, seeing the world primarily in shades of blue, gray, green, and yellow. If their dreams are constructed from the visual information their brain processes during waking hours, and this extrapolation is based on what we know about how mammalian visual systems work, then their dream worlds might be rendered in these same muted but beautiful tones. It's speculation, certainly, but it's speculation grounded in what we understand about sensory processing and memory. One of the most touching possibilities about cat dreaming is that they might dream about us, about their human companions. Research on dogs has shown that dogs' brains respond to the sight and smell of their owners in ways that suggest genuine affection and bonding. While fewer such studies have been done with cats, the available evidence suggests similar mechanisms may be at play. The cat curled up on your bed right now. Given what we know about how memory consolidation works during sleep, how the brain replays significant experiences from waking hours, it's reasonable to think they might be dreaming of you, of the comfort of your presence, of the sound of your voice calling them for dinner, of the feeling of your hand stroking their fur. We can't peer into their dreams to know for certain, but the neuroscience of memory and emotion suggests it's entirely possible. It's a humbling thought. As we dream of places we've never been and people we've never met, our cats dream of their actual lives, and we are part of those dreams. The language of sleeping positions. If you've spent any time around cats, you've noticed they sleep in a remarkable variety of positions. Some of these positions look comfortable. Others appear to defy the laws of physics and orthopedics. But these positions aren't random. Each one tells us something about how the cat is feeling, about their level of comfort, their sense of security, their body temperature, even their health. Let's start with the most common position, the curl. In this classic pose, the cat tucks their paws underneath their body and wraps their tail around themselves, creating a compact crescent shape. Their head typically rests on their front paws or is tucked down toward their chest. From certain angles, they look almost like a cinnamon roll. Warm, cozy, and perfectly self-contained, the curl serves multiple functions. First, it's thermally efficient. By pulling their limbs close to their core and using their tail as a blanket, the cat minimizes heat loss. This is an ancestral behavior. In the wild, where temperature fluctuations could be extreme, the ability to conserve body heat while sleeping was crucial for survival. Even in modern homes with climate control, cats instinctively curl up when they feel even slightly cool. Second, the curl protects vital organs. The soft, vulnerable belly, which houses the intestines, liver, kidneys, and other essential organs, remains safely enclosed within the curl of the body. The muscular legs and the skeletal rib cage form a protective barrier. In the wild, where a sleeping cat might be vulnerable to attack, this position offered important protection. Third, the curl allows for quick mobilization. A cat sleeping in this position can uncurl and spring to their feet in a fraction of a second. They're never fully committed to deep relaxation. There's always an element of readiness, of maintaining the option for rapid escape or defense. Now consider the opposite end of the spectrum, the belly-up position. In this pose, the cat lies on their back with their legs spread wide, their belly fully exposed, their paws either dangling limply at their sides or folded on their chest. It's arguably the most endearing sleeping position, and it's also the most significant. When a cat sleeps belly up, they're making a profound statement of trust. Remember, the belly is their most vulnerable area. In the wild, exposing it while sleeping would be extremely dangerous. A cat only sleeps in this position when they feel absolutely, completely safe, when they trust their environment and the beings in it. If your cat sleeps belly up near you, or better yet, on you, that's the highest compliment a cat can pay. They're telling you they feel secure in your presence. However, and this is important, a belly-up sleeping position is not an invitation to touch the belly. Many people make this mistake. They see the exposed belly and instinctively want to pet it. But cats, even the most trusting cats, often have a low tolerance for belly touching. The instinct to protect that vulnerable area is deeply ingrained. Touch the belly of a sleeping cat, even a cat who sleeps belly up, and you might get a face full of claws as they instinctively defend themselves. Then there's the side sprawl. The cat lies on their side with their legs extended, sometimes stretched to maximum length, sometimes slightly curled. This position indicates a moderate level of relaxation and security. The cat isn't quite as vulnerable as in the belly-up position. They can still protect their belly somewhat, and they can roll onto their feet relatively quickly if needed, but they're comfortable enough to relax significantly. Cats often adopt the side sprawl on hot days or in warm environments. Stretching out increases their surface area, allowing heat to dissipate more efficiently. You might notice your cat sprawling on cool tile floors or in front of fans when the weather is warm. Conversely, on cold days, that same cat will curl into the tightest ball possible. The loaf position deserves special mention because it's both common and somewhat ambiguous. In this pose, the cat sits upright or crouches with all four paws tucked completely underneath their body. They look remarkably like a loaf of bread, hence the name that's become popular in internet cat culture. The loaf indicates the cat is relaxed but not deeply asleep. They're comfortable and calm, but maintaining a level of alertness. They could spring into action quickly if needed, but they don't feel any immediate threat. Many cats loaf while observing their environment, watching birds through a window, surveying their territory from a high perch, or simply keeping an eye on household activities. It's the feline equivalent of a vigilant but comfortable rest. Some sleeping positions should raise concern. A cat who suddenly starts sleeping in unusual locations, in their litter box, for instance, or pressed up against walls, might be ill. A cat who sleeps with their head extended and neck stretched out might be having trouble breathing. A cat who seems unable to find a comfortable position, who shifts repeatedly, or seems restless during sleep might be in pain. Changes in sleeping positions can also indicate changes in the household dynamic. A cat who previously slept in exposed, vulnerable positions but suddenly starts seeking hidden, protected spots might be feeling stressed. Perhaps there's a new pet in the home. Perhaps there's construction noise outside. Perhaps the cat's favorite human has been absent. Cats are sensitive creatures, and their sleeping behaviors reflect their emotional states. Where a cat chooses to sleep is equally revealing as how they sleep. A cat who sleeps on your bed, particularly near your head or chest, is demonstrating affection and trust. They want to be close to you. They find your presence comforting. Some researchers suggest that cats who sleep near their human's head may be drawn by the warmth and the scent of their person, which is strongest in this area. A cat who sleeps near but not directly on you might be showing love while also maintaining some independence. Very cat-like behavior indeed. Cats who sleep in high places, on top of refrigerators, on high shelves, in tall cat trees, are expressing their natural inclination to survey their territory from an advantageous position. Height equals security in the feline world view. From high places, they can see potential threats approaching and are themselves less vulnerable to ground-level dangers. This behavior is deeply rooted in their wild ancestry, where climbing trees provided safety from larger predators. Cats who sleep in enclosed spaces, in boxes, in cupboards, under beds, in cat caves, are satisfying their instinctive need for den-like security. These enclosed spaces feel safe and protected, reminiscent of the hollow trees or rocky crevices their ancestors might have used. There's a reason the internet is filled with pictures of cats squeezed into impossibly small boxes. Those boxes represent perfect sleeping spots, safe, snug, and satisfying on a deeply instinctual level. The enclosed space also helps retain body heat and provides sensory input from all sides, which many cats find comforting. Some cats exhibit what's playfully called the monorail position, sleeping draped over narrow surfaces like stair railings, fence tops, or the arms of couches, with their legs dangling on either side. This position, also seen in large wild cats who sleep in tree branches, allows the cat to feel secure while remaining somewhat elevated. It's actually quite comfortable for their flexible spines, and it keeps them cool when temperatures are warm. Then there's the Superman position, where the cat lies on their stomach with their front and back legs stretched out fully behind and in front of them. This position is particularly common in kittens and young cats, often seen after vigorous play sessions. It allows for maximum cooling of the body and also suggests the cat is merely taking a quick rest before the next bout of activity. Where a cat chooses to sleep is equally telling. A cat who sleeps on your bed, particularly near your head or chest, is demonstrating affection and trust. They want to be close to you. They find your presence comforting. A cat who sleeps near but not directly on you might be showing love while also maintaining some independence. Very cat-like behavior. Cats who sleep in high places, on top of refrigerators, on high shelves, in cat trees, are expressing their natural inclination to survey their territory from an advantageous position. Height equals security in the feline world view. From high places, they can see potential threats approaching and are themselves less vulnerable to ground-level dangers. Cats who sleep in enclosed spaces, in boxes, in cupboards, under beds, in cat caves, are satisfying their instinctive need for den-like security. These enclosed spaces feel safe and protected, reminiscent of the hollow trees or rocky crevices their ancestors might have used. There's a reason the internet is filled with pictures of cats squeezed into impossibly small boxes. Those boxes represent perfect sleeping spots, safe, snug, and satisfying on a deeply instinctual level. During sleep, cats may change positions multiple times. They might start in a cautious loaf, transition to a relaxed curl as they drift deeper into sleep, then shift to a side sprawl or even belly-up position during REM sleep, when muscle atonia prevents them from maintaining more controlled postures. Watching these transitions offers a window into the cat's sleep cycle, an external manifestation of internal states. The positions cats adopt while sleeping with other cats or with humans reveal social bonds and relationships that are often more nuanced than we realize. Cats who curl up together, touching at multiple points, who groom each other before sleeping, who purr together. These are cats with strong social connections. The shared body heat is pleasant, yes, but the companionship appears to be equally important. Research has shown that cats who have positive relationships often synchronize their sleep cycles, entering and leaving sleep stages at similar times. Cats who merely tolerate each other might share a sleeping surface, but maintain space between their bodies, perhaps a few inches of neutral territory. They're comfortable enough to be in proximity, but they're not bonded closely enough to want direct contact. Cats who genuinely like each other intertwine, one cat's tail draped over another's back, heads tucked together, paws overlapping. The cat puddle phenomenon, when 3 or more cats pile together in a sleeping heap, is particularly charming and represents a high level of social harmony. This behavior is more common in cats who were raised together from kittenhood or who have lived together for many years. The position at the center of the pile is often sought after, as it's the warmest spot. You might notice cats taking turns in the center position across different sleep sessions, a kind of fair weather sharing. And when your cat chooses to sleep on you, when they settle their full weight on your lap, or sprawl across your chest, or curl up next to your legs, or drape themselves over your feet, they're not just seeking warmth, though that's certainly part of it. They're choosing your company. They're telling you, in the clearest way they know how, that you are part of their safe space. You are part of their world. You are, in the best possible sense, part of their pride. The weight of a sleeping cat is a kind of blessing, a living reminder of trust freely given. And when your cat chooses to sleep on you, when they settle their full weight on your lap, or sprawl across your chest, or curl up next to your legs, they're not just seeking warmth, though that's certainly part of it. They're choosing your company. They're telling you in the clearest way they know how that you are part of their safe space. You are part of their world. You are, in the best possible sense, part of their pride. Dreams reflect waking life. The relationship between a cat's daily experiences and their dream content is more than just theoretical speculation. Multiple lines of research confirm that what happens during waking hours directly influences what happens during sleep. The clearest evidence comes from studies of memory consolidation in both humans and other mammals. Sleep, particularly REM sleep, plays a crucial role in converting experiences from temporary, fragile short-term memories into stable, long-term memories. This process isn't passive. It's not like saving a file to a hard drive. Instead, the brain actively replays experiences, reinforces important neural pathways, and integrates new information with existing knowledge. For cats, this process is particularly important for motor skills and spatial memory. Think about a kitten learning to hunt. They need to master complex sequences of behavior: the stalk, the crouch, the wiggle of the haunches, the explosive pounce, the bite that severs the prey's spine. These sequences require precise coordination between visual processing, motor planning, and execution. They must be practiced, refined, and eventually automated so they can be performed without conscious thought. The neurobiological mechanisms underlying this learning process are remarkable. During waking hours, as the cat practices these movements, Specific neural circuits fire in specific sequences. The synapses, the connections between neurons, are strengthened through a process called long-term potentiation, but this strengthening is initially fragile. It needs to be consolidated, made permanent. That's where sleep comes in. Studies show that after learning a new motor skill, animals, including cats, show increased REM sleep. During this REM sleep, the brain regions involved in motor control show heightened activity. The brain is essentially practicing the skill during sleep, strengthening the neural circuits without the need for actual physical practice. This is why kittens sleep so much. They're not lazy. Their brains are working overtime, consolidating all the new skills they're learning during their waking hours. Adult cats do this too. Introduce a new climbing structure to your home, and your cat will explore it enthusiastically. That night, as they sleep, their brain will replay those movements, cementing the spatial map of this new territory, reinforcing the motor patterns for navigating it. The next day, they'll move through that structure with greater confidence and precision. The emotional content of waking experiences also influences dream content in profound ways. Research on humans shows that emotionally charged events are more likely to appear in dreams than neutral events. The same appears to be true for animals, and cats are no exception. A cat who experienced something frightening, a loud noise, an encounter with a threatening animal, a painful injury, may replay that experience during sleep. You might notice them sleeping more fitfully on such nights. They might wake more easily, appear more agitated during REM periods, or show signs of distress even while sleeping. This isn't the brain tormenting the cat with bad memories. It's actually therapeutic. By replaying emotional experiences during sleep, in the safe context where no actual threat exists, the brain can process them more effectively. The threatening dog from the afternoon appears in the dream, but it can't actually hurt the sleeping cat. The brain can explore different responses, integrate the experience into the cat's understanding of the world, and gradually reduce the emotional charge associated with the memory. This process, sometimes called emotional depotentiation, is remarkably similar to the role dreams play in human emotional regulation and trauma processing. It's one reason why sleep deprivation can have such devastating effects on emotional health. The brain is denied the opportunity to process and integrate difficult experiences. Positive experiences also feature prominently in dreams. A particularly successful play session, a delicious meal, affectionate interactions with beloved humans. These pleasant experiences get replayed too. Watch a cat sleeping after a vigorous play session with a feather wand toy. You might see their paws making swatting motions, their body tensing as if preparing to pounce, their whiskers twitching with excitement. They're dreaming of the hunt, reliving the satisfaction of the catch, consolidating the motor patterns that made them successful. The environment in which a cat sleeps influences the content and quality of their dreams. A cat who sleeps in a quiet, secure room with minimal disturbances is more likely to have restful sleep with predominantly positive dream content. Their sleep cycles progress normally. They achieve adequate amounts of deep, slow wave sleep for physical restoration and sufficient REM sleep for memory consolidation and emotional processing. A cat who sleeps in a chaotic environment with unpredictable noises, disruptions, and potential threats will experience more fragmented sleep. They'll have more brief awakenings, less deep sleep, and potentially more stress-related dream content. This is why it's so important to provide cats with safe, comfortable sleeping spaces where they can rest without disturbance. Ideally, multiple options in different parts of the home. so they can choose based on their current needs and preferences. Interestingly, what cats don't experience during waking hours may also shape what appears or doesn't appear in their dreams. A cat who has lived their entire life indoors, who has never hunted real prey, will still dream of hunting because the instinct is innate, hardwired into their neural circuitry by millions of years of evolution. But the specific prey animals in their dreams might be unusual or abstract. They might dream of hunting the red dot from a laser pointer, that maddening, uncatchable point of light. They might dream of the feather toy, or even household insects. Their dreams are constructed from the materials their waking experiences provide, filtered through their instinctive behavioral templates. This creates an interesting question. Do indoor cats dream differently than outdoor cats? While we can't peer directly into their dreams to know for certain, behavioral observations and what we understand about memory consolidation suggest the answer is yes. An outdoor cat has access to a richer, more complex sensory environment. They encounter real prey, mice, birds, insects. They navigate varied terrain. They interact with other cats and animals. They experience weather changes, seasonal shifts, the full spectrum of natural light. All of this provides raw material for dreams. An indoor cat's experiences are more limited in scope, though not necessarily in emotional significance. They may dream of looking out windows at birds they can never reach. A kind of dreaming about dreaming, perhaps. They may dream of the daily routines that structure their lives, the sound of the can opener, the ritual of mealtime, the comfort of their favorite sunny spot. Their dreams might be more focused on their human relationships, on the social dynamics of the household, on the subtle changes in their domestic environment. Neither type of dream life is superior. They're simply different, reflecting different waking realities. There's also evidence from studies on other mammals that suggests animals can learn during sleep. Research on rats shows that those who sleep after learning a maze navigate it more efficiently the next day than rats who were kept awake. The sleeping brain isn't just reviewing the experience, it appears to be optimizing it, finding more efficient strategies, making connections. While similar studies haven't been conducted specifically on cats, the shared mammalian brain architecture suggests your cat might do the same thing. That puzzle feeder that baffled them yesterday, after a good night's sleep, during which their brain may have replayed attempts to access the food and unconsciously explore different approaches, they might solve it more easily in the morning. The new cat tree that seemed daunting, a few sleep cycles later, they could have mentally mapped more efficient routes to the top. This is extrapolation based on what we know about mammalian cognition, but it's grounded in solid neuroscience. This is why adequate quality sleep is so crucial for cats' cognitive function and overall well-being. A cat who is chronically sleep-deprived, either because of environmental disturbances or health issues, will show impaired learning, memory, problems, and behavioral issues. They might become more irritable, less coordinated, or show reduced interest in activities they normally enjoy. Just as with humans, sleep isn't optional for cats. It's essential for proper brain function. The relationship between waking life and dream content also explains why changes in a cat's environment or routine can affect their sleep. A cat who recently moved to a new home might show disrupted sleep patterns for weeks. They're processing the change, integrating new spatial information, adjusting to new sounds and smells. Their dreams might be filled with images of the old home mixed with the new as their brain works to reconcile the change. Similarly, the loss of a companion, whether another cat, a dog, or a human family member, can profoundly affect a grieving cat's sleep. Behavioral observations suggest they might dream of the lost companion. They might wake more frequently, perhaps searching for the familiar presence that's no longer there. While we can't peer directly into their dreams, the changes in their sleep patterns and waking behavior, the searching, the vocalization, the disrupted rest, suggest they're processing the loss not just during waking hours, but potentially during sleep as well. This brings us to a beautiful truth about cat consciousness. Their dreams, like ours, are deeply personal. Each cat's dream life is unique, shaped by their individual experiences, temperament, and history. The stray who survived by their wits dreams different dreams than the pampered house cat who has never known hunger or fear. The bold, confident cat dreams differently than the shy, anxious cat. The young cat full of energy dreams differently than the elderly cat whose best adventures are memories. Understanding this, understanding that our cats have rich inner lives that continue even while they sleep, should deepen our appreciation for these remarkable creatures. They're not simple beings driven only by instinct. They have memories, emotions, experiences that matter to them. They have, in a very real sense, a subjective experience of existence. And every night, as they curl up in their favorite spots, as their breathing slows and their eyes close, they carry that existence with them into dreams. Conclusion. We've traveled tonight through the hidden world of feline sleep, from the sun-baked savannas where cats first evolved their remarkable sleep patterns, through the laboratories where dedicated scientists decoded the mysteries of REM sleep, into the very structure of the dreaming cat brain, and finally to the personal, individual dream lives of the cats we share our homes with. What have we learned? That cats are not the simple creatures they sometimes appear to be. Behind those inscrutable eyes lies genuine consciousness, genuine experience. When your cat sleeps for 16 hours a day, they're not being lazy. They're following millions of years of evolutionary programming. They're consolidating memories, processing emotions, rehearsing behaviors, repairing their bodies. And yes, they're dreaming. They dream of hunts, both real and instinctive. They dream of play, of exploration, of social interactions. They dream of threats survived and challenges overcome. They might even dream of you, of your voice, your touch, your comforting presence. Their dreams are constructed from the same raw materials as ours: memory, emotion, and imagination. The positions they sleep in, the places they choose to rest, the twitches and murmurs they make during REM sleep, all of these are windows into their inner lives. A cat sleeping belly up on your bed is expressing profound trust. A cat twitching and paddling their paws is reliving some great adventure. A cat who sleeps curled tightly in a hidden spot might need more security, more reassurance that they're safe. Understanding cat sleep. Understanding that it's not just downtime, but an active and essential part of their cognitive and emotional life, should change how we care for our feline companions. It means ensuring they have quiet, comfortable, secure places to sleep. It means respecting their need for rest and not disturbing them unnecessarily. It means paying attention to changes in their sleep patterns, as these might indicate health problems or emotional distress. It also means appreciating the privilege of sharing our lives with these creatures. When a cat chooses to sleep near us, they're expressing something meaningful. They're saying, through their actions, if not their words, that we are part of their safe world. That in the vulnerability of sleep, when predators might strike and dangers might lurk, they trust us enough to close their eyes. The science of cat sleep has come a long way since Michel Jouvet first observed those sleeping cats in Lyon and realized something profound was happening in their minds. We now know that dreaming is not uniquely human. It's not even uniquely mammalian. It appears to be a fundamental feature of complex nervous systems, a way for brains to process information, maintain psychological health, and prepare for future challenges. But perhaps more important than any scientific discovery is the simple recognition that our cats are more than pets. They're conscious beings with inner lives, with experiences that matter to them, with joys and fears and memories, and yes, with dreams. They share our homes, our hearths, and sometimes our beds. And in return, they invite us, if we're paying attention, into a deeper understanding of consciousness itself. So tonight, when you settle into sleep, take a moment to observe your cat if they're nearby. Watch their breathing slow. Notice when they slip into deeper stages of sleep. If they're in REM, watch for those telltale signs, the eye movements, the twitches, the soft sounds, and know that in that moment, they're somewhere else. They're running through dream grass under a dream moon, chasing dream prey, living a life that exists only in the private theater of their sleeping mind. And tomorrow, when they wake, stretched and yawning and ready for breakfast, they'll carry those dream experiences with them into waking life, just as we carry ours. They'll be a little bit changed by what they experience during sleep, their brains a little bit rewired, their memories a little bit more consolidated. They'll be ready for another day of being magnificently, mysteriously, beautifully cat. Before I let you drift off to your own dreams, I have a small request. If you've enjoyed this journey into the secret world of cat sleep, if you've learned something new about these remarkable creatures, I'd be grateful if you'd take a moment to leave a like on this video. And if you'd like to explore more mysteries of animal minds with me, consider subscribing to Wild Slumber. We have so many more stories to tell, so many more wonders to discover in the natural world. Until next time, may your sleep be deep, your dreams be pleasant, and may you always have a warm cat purring beside you. Rest well, dear friends. The night is long, and dreams are waiting. Sweet dreams.